talking about the end behavior of the graphs. Now remember, when you're talking about end behavior, you want to look at the leading term, the term that has the highest exponent. So on number 1, I guess it's p of x. You have negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 5. So when I'm talking about the leading term, it's not always the term in the front. It is in this case. But the leading term is the term that has the highest exponent. That's what gives your graph its end behavior. The term with the highest exponent is that one. It does happen to be up front this time. So you're looking for two things. You're looking for its exponent and its sign. This, if your exponent is even, that gives it what's called an even end behavior, which means the ends of the graph are going to be the same, either both up or both down. That's what an even end behavior tells me. The sign is what tells me whether they're up or down. What does the negative do to you? Flips you upside down, right? So that's why the end behavior would be that one right there, both going down. All right, number 2, since number 2 is dealing with the same topic, it's also end behavior. I'm just going to write it right below this. F of x equals negative 3.4x to the 4th plus x to the 6th plus 0.7x to the 7th. So this time the term with the highest exponent is actually this one back here, right? There's your highest exponent. That's what's going to give the graph its end behavior. This time the exponent is odd. Now, odd end behaviors are one up, one down. So it can either be like that or like that. Where am I? So this one right here, its sign is positive, which means from the left side, if you're reading the graph like a book from the left side to the right side, it's going to go up. So that's why this one right here, since it's going to go up throughout the graph and end up on the other side, that one is positive. This one starts from the left, but it goes down. That's a negative odd end behavior. So that's why it's not that one, it's this one for the positive sign. Number 3. So now we're into finding the zeros of polynomial functions and their multiplicities. Now remember, when you're finding zeros, what's nice is if you see the factorization, because if you see the factors, then you just set your factors equal to 0 and solve them for x. So on number 3, the function is f of x equals x squared minus 4 to the 4th power. So if you look inside the parentheses, that's not all the way factored, right? If you see an x squared, you're going to be able to factor that again to get the complete factorization. So this one is, so x squared minus 4 is a difference of perfect squares, right? So I'm going to rewrite this out as the difference of perfect squares. So let's see, x squared will be x and x. The perfect square of 4, since it's a perfect square, I'm going to use 2 and 2 to get it. 1 positive, 1 negative. Now, this exponent, if this is all to the 4th power, that means even when I factor it out, they're still both to the 4th power. It's just that now they're completely factored. So my factors are what turn into the zeros. So x plus 2 equals 0 and x minus 2 equals 0. and then solve them for x. So subtract the 2's here, so x equals -2. Here, add the 2's to get x equals +2. So those are your zeros, positive and -2. And the multiplicity of each of those, this is what gives it its multiplicity, the exponents. They each have a multiplicity of 4. So the zeros are positive and -2, and they both have multiplicity of 4. Right, number 4. Finding zeros and their multiplicities again. All right, so it's nice on number 4, this one is already, everybody's already factored out, right? There's no exponents inside any of these. So I can turn those automatically straight into their zeros and list their multiplicities. So let's see. This doesn't have an x, so it doesn't make a 0. This does. So x minus 2 equals 0. Solve it for x. So add the 2 to both sides. So x equals 2. So there's one of the zeros. And its multiplicity is what? 4. Solve this one for x. So x plus 4 equals 0. So subtract the 4's from both sides to get x equals -4. So there's another 0 at -4. Its multiplicity is 3. And here's another factor with an x. So if I set that factor equal to 0 and solve it for x, it's already solved once you set it equal to 0. So 0 is another 0, and its multiplicity is 2. Okay? It kind of asks you all the answers in a different way, okay, on the sheet and on the review. So the 0, 2 has a multiplicity of blank. So where's my 0, 2? There's the 0, 2. Its multiplicity is 4. The second part says blank is a 0 of multiplicity 3. So here's multiplicity 3. Its 0 is -4. And then it asks for the remaining 0. So the remaining 0 is 0, and its multiplicity was 2. So this one was nice. It asked me to find zeros, and it was nice enough to go ahead and completely factor this, right? Everything was in nice, neat factors. So I just set the factors equal to 0 and solved them for x. On number 5, again, it asked me to find the zeros, but it's not in its factored form, right? Doesn't have all the nice, neat, laid out factors where we can set them equal to 0 and solve them for x. So we have to do the factoring ourselves, okay? When I'm looking at this, I see 4 terms. Anytime I need to factor and I see 4 terms, I'm going to put them in groups of 2. Group the first 2 and group the second 2. And then I'm going to pull out the factors from each of the groups. So let's see, what's in common here? I can pull out an x squared from that first group. If I took out an x squared from both of these, let's see, if I took out x squared from that first term, I'll still be left with an x. Minus, if I took the x squared out of this term, I'll just be left with that 8. So there's the first group factored. Now I want to pull what's in common out of my second group. When I'm looking at this, I don't really see anything in common. Now, when you are factoring by grouping, you're going to want this second parentheses to match this first parentheses because that's going to be one of your factors. What's wrong with this one? It has a negative x plus 8, but it needs to be the opposite of that. So I've got to pull the number out that changes signs, which is always negative 1. If I divide those by negative 1, I get x minus 8. So there's one of your factors. What's in common? X minus 8. The other factor is the two terms that you pulled out, which is x squared minus 1. So I still have x squared, which means that can continue to factor. Now it's a difference of perfect squares, right? X and x for x squared. 1 and 1 for 1. 1 positive, 1 negative. I'm just going to bring this factor down because it was done. So there's the factorization. Now, once you have factors, what can you do with those? Set them equal to 0 and solve them for x. So x minus 8 equals 0, x plus 1 equals 0, and x minus 1 equals 0. And solve them for x. So add the 8s here. So x equals 8. Subtract 1s here. So x equals negative 1, and add the 1s here. So x equals positive 1. So there's your 3 zeros. 8, negative 1, and positive 1. And then what else does it want to know about this is what are the multiplicities of each of these zeros? Now remember, the multiplicities are the exponents that are above the factors that those zeros came from. Here's the 0, which means here's its factor. Its multiplicity is 1. Same thing here. Here's the 0, here's its factor, multiplicity 1. Here's its 0, that means it came from this factor. So they all had multiplicity of 1. All right, number 6. Another question on multiplicities. Now remember, what multiplicity does is it determines at that 0 whether or not you're going to cross the x-axis or if you are going to touch it and go the other way at that x-intercept, okay? So what makes that happen is whether the multiplicity is even or odd. Okay, concerning multiplicity, when you are even, your exponent is even, which means your multiplicity is even. That means you are going to be an x-intercept that is tangent to the x-axis. Tangent is the word that we use when it comes, it touches the x-axis and goes the other way. If your multiplicity is odd, you are going to cross all the way through the x-axis at your x-intercept. So let's use that knowledge to answer whether or not this is true or false. P of x equals x minus 3 to the 4th, x plus 4 to the 3rd. And it wants to know, is this true or false? It says this graph crosses the x-axis at 3, 0. So here's the x-intercept. It says that x is going to be 3, which means what factor did that x-intercept come from? Well, if 3 is the x-intercept or the 0, it came from this factor, right? So this is the factor that we're talking about. What's its multiplicity? 4, which means it's even, which means this x-intercept is going to be tangent to the x-axis. So this word right here makes that statement false, right? It's going to be tangent to the x-axis at 3, 0 because its multiplicity is even. It's just like A, right? Number 7. Talking about the maximum number of zeros, x-intercepts, and turning points of a function. So the function is f of x equals negative 5x minus x to the 6. And it wants to know the maximum number of zeros, maximum x-intercepts, and maximum turning points. All right, the maximum number of zeros and x-intercepts are going to be the same, aren't they? Aren't your zeros? Those are your x-intercepts. The maximum number of those are going to be the same. All you look for is the highest exponent. So your maximum number of x-intercepts and zeros would both be 6. The maximum number of turning points is whatever this exponent is, the highest exponent, minus 1. So you just take 1 away. So it will be 5. I have sunburn and my nose is peeling and this mask is gonna itch me to craziness. Number 8. Sketch the graph of this polynomial function. H of x equals x, x minus 3, x plus 4, x minus 4. So let's think about the end behavior first. So if I was talking about end behavior, that would mean I would have to think of all those x's distributed to each other. So if I was going to multiply all that together, x times x times x times x, I'm going to end up with x to the 4th. So it would be positive and even. An even end behavior that's positive means both ends of the graph should be going up, okay? That in itself answers this problem since it's multiple choice. When you're looking at all these, A, both ends up. This one's down, up, both down. That answers the question, just knowing the fact that that would be a positive even end behavior. If it didn't, if it is in its factored form like this, just turn all those into zeros. Those are your x-intercepts. So this one would be 0, x minus 3. If I set that equal to 0 and solved it, it would turn into positive 3. This will turn into negative 4. That'll turn into positive 4. Those are the zeros, or in other words, the x-intercepts. So you would just look at the x-axis and find the graph that crosses the x-axis at those 4 numbers if the end behavior didn't get it for you. Number 9. sketch the graph, f of x equals 6x to the third minus 4x squared minus 54x plus 36. So this one again, I can start off with end behavior. Let's see, this one's odd and positive, which means it's going to start at the bottom and travel up throughout the graph, which gets me part of the way there, right? It knocks out B and C. A and D, first of all, look very similar. They both start at the bottom and go up. Start at the bottom and go up. So I've got to find something else that's going to distinguish which one this is. This one is not written out in nice, neat factors, so it's not going to be super easy to find the zeros. If it's written out, the whole polynomial function all the way written out, the easiest thing to find from that information is the Y-intercept. Right? How do you find the Y-intercept? You think of all the terms that have x's, you kind of think of those as just being gone, right? Because if I replace all those x's with zeros, which is how you find your Y-intercept, what's it going to do to this? 0 to the third is 0 times 6 is 0. Going to knock that out. It's also going to knock this out. It's also going to knock that out. So all you're going to be left with was any term that didn't have an x to plug in a 0. So you're going to be left with a positive 36. That's where it's going to cross the y-axis. Look at the difference between A and D. If you look at D, it's crossing through right at the origin. A is crossing a little above the origin, so it doesn't look like it's 36, but look what the top number is. That's 250. Which means each of these little hash marks is a 50. So even though it doesn't look like it's crossing it very high, 36 wouldn't be very high if your hash marks are 50s, right? So that's why it is A. Number 10, synthetic division. It wants to know if -3 and 1 or 1, either one of those are zeros of this polynomial function. H of x equals x to the fourth plus 4x to the third plus 3x squared minus 6x minus 2. First thing it wants me to do is see, is -3 a 0 by using synthetic division. So when we're using synthetic division, what we care about from each of these terms is just the number part, the coefficient of it. So I've got 1, 4, 3, -6, and -2. Now remember the flow of synthetic division. Drop down your first number. 1. Then do the multiplying. -3 times 1 and put your answer there. So -3 times 1 gives me -3. And then combine that straight down. 4 minus 3 is 1. Then do it again. -3 times 1, -3. When I combine that straight down, I get a 0. And do it again. Keep going all the way to the end. -3 times 0 is 0. Combine that straight down, I get -6. And last one, -3 times -6 is positive 18. When I add that straight down, I get a 16. The only way that -3 is a 0 of this function is if this ends up 0 right here. So since it ended up 16, the answer is no. -3 is not a 0. And it wants me to do the same thing with 1. check it. Same coefficients. So 1, 4, 3, negative 6, negative 2. I'll drop down the 1. Whoops, give me something in my room. Okay, drop down the 1 and start your multiplying. 1 times 1 is 1. Add that straight down, it gives me 5. Do it again. 1 times 5 is 5. Add that straight down, it gives me 8. 1 times 8 is 8. Add that straight down, negative 6 and 8 is 2. And 1 times 2 is 2. So when I do add that straight down, I do get a 0, which just means, yes, 1 is a 0 of the function. Number 11. All right, find a polynomial function with degree 4, which means at the end, once I figure out all this and multiply everything together, so degree 4 means my first term is going to be an x to the 4th term. Okay? It tells me that negative 3 is a 0 of multiplicity 3. And 0 is a 0 of multiplicity 1. So I know the zeros of the function. It wants me to find out what is the function that has those zeros. If I know the 0, I can go backwards now. I'm going to go from 0 to the factor that it came from. Once I have the factors written out, I can multiply the factors together. That's going to give me the whole long list of polynomial functions. So if negative 3 is a 0, what factor did it come from? It must have come from x plus 3. The multiplicity of this 0 was 3, which tells me the exponent of that factor is 3. 0, what factor would that come from? That would just come from an x, right? X equals 0. Its multiplicity is a 1, so its exponent is a 1, which means I don't even need to write it. Now, that's the easy part. What is x plus, now I have to multiply all this together. X plus 3 to the 3rd power means what? I'm going to do it over here. X plus 3 times itself 3 times. So I'm going to FOIL here. X times x is x squared. X times positive 3 is positive 3x. And my inner, positive 3 times x is another positive 3x. Positive 3 times positive 3 is positive 9. I can combine those x's in the middle. I really have 6 x's all together there. So I've got x squared, put those together to get 6x plus 9. I still have this x plus 3 I got to multiply. So here, I'm going to distribute the x squared to both of those. X squared times x is x to the 3rd. X squared times 3 is 3x squared. Then I'll distribute my 6x to both of these also. 6x times x is 6x squared. 6x times positive 3 is positive 18x. And then distribute the last term. So I'm distributing the 9 to both of these. 9 times x is 9x. And 9 times 3 is 27. So I just need to clean that up. When I clean it up, I'm going to write it under where it came from, which is this right here. I don't have any other x to the third, so I'll just bring it over. I can put my x squareds together. When I put my x squared, I've got 3 and 6, so I really have 9x squareds. I can put my x's together. I've got 18 and 9, which gives me 27x. And then I'll just bring over the other 27, this number right here. Didn't have anything to combine with. So I'm not to degree 4 yet, I'm to degree 3. But remember, this just came from x plus 3 to the third. I still have to multiply all this times that x. That's where your degree 4 is going to come from distributing this x to all those terms. So I've got x times x to the third, which is x to the fourth, times 9x squared gives me 9x to the third. X times 27x gives me plus 27x squared, and x times 27 is 27x. So that's the polynomial function that came from those zeros. If you put this in your y equals, you would see it's going to cross the x-axis at -3 and 0. Number 12. Now, on number 12, this is going to go with the knowledge that if one of your zeros is a square root or an I, those zeros come in conjugate pair factors, which means if you have a zero that is a square root or an I, the opposite of it is automatically also a zero. So on number 12, if it tells you that negative I is a 0 and so is 3 minus the square root of 5, it's just asking for the other zeros. What other zeros could there possibly be? Well, if I is a 0, if negative I is a 0, then so is positive I. If 3 minus the square root of 5 is a 0, then so is 3 plus the square root of 5. Those are your other zeros. All right, so don't make that one any harder than it is. Number 13 is going to ask us to find the other zeros and also come up with the polynomial function that they came from. So number 13, it tells me that the square root of 5 is a 0, and it also tells me that 5i is a 0. Well, if the square root of 5 is a 0, so is the opposite of it. If 5i is a 0, so is negative 5i. So it wants us to take this one step further here. It wants us to find the polynomial function that created those zeros, which means turn each of those zeros into the factor that they came from and then multiply them all together again. So if this is a 0, where did it come from? X minus the square root of 5. If this one is a 0, then it came from x plus the square root of 5. If this is a 0, it came from x minus 5i. Then this one came from x plus 5i. So look in here. When you are multiplying conjugate pairs together, what are you going to do? You're going to FOIL this together, and then I'm going to FOIL this together. The good thing about when you're multiplying conjugate pairs together is you can kind of take a shortcut in the FOIL. Conjugate pairs look like this. They have everything the same, but the sign in the middle is different. So I'm going to FOIL. X times X is X squared. Here's the shortcut I'm talking about. You don't have to do the outers in the inner part of FOIL because look what's going to happen. My outers would give me positive X square root of 5. What would your inner give you? Negative X square root of 5. They're going to cancel each other out anyway. So I can jump straight to my last. So negative times positive gives me negative. The square root of 5 times the square root of 5 is the square root of 25. 5. That's just plain 5, right? So this really is just X squared minus 5 is what's left there. Let's do the same thing on this other one. X times X gives me X squared. Again, since they're conjugate pairs, I can jump straight to my last. Negative times a positive gives me a negative. 5i times 5i is 25i squared. But what is I squared equal to? Since it's equal to negative 1, this really says X squared. Negative 25 times negative 1 actually turns it into positive 25. Then FOIL that. X squared times X squared gives me X to the 4th. I do have to do the whole FOIL here, right? Because those are not conjugates of each other. So my outer X squared times positive 25 is 25X squared. My inner, negative 5X squared. And my last, negative 5 times positive 125, or excuse me, negative 5 times positive 25 is negative 125. And then when you put your terms in the middle together, they're like terms, they're both X squared, you'll have X to the 4th plus 20X squared minus 125. Number 14. F of X equals X to the 3rd plus 2X squared minus 3X minus 6. It gives me one of the zeros of the function and asks me to find the others. You remember, when best case scenario is when you're finding zeros for it to be quad, right? For it to be X squared, because then you can just cheat and go to your quad program to find zeros. But let's look at number 14. You've got F of X equals X to the 3rd plus 2X squared minus 3X minus 6. And it wants to know, it tells me negative 2 is a 0. Okay, I need to find the remaining zeros. Well, if I have X to the 3rd, that means there's a maximum of 3 zeros. It gave me one of them, negative 2. So what I'm going to do is I'm going to use negative 2 and do synthetic division with it. Let's see what that does for me. So if I do negative 2 synthetic division using these coefficients, it'll be 1, 2, negative 3, negative 6. Doing the synthetic division. Drop down your 1. Negative 2 times 1 is negative 2. Combine that straight down, you get 0. Negative 2 times 0 is 0. Add that straight down, you get negative 3. And the last one, negative 2 times negative 3 is positive 6. So when you add that straight down, you do get a 0, which we knew we would. It told us negative 2 was a 0, so we knew that was going to be the result right there. Here's the thing. The solution is this. Those are the coefficients of a polynomial function starting with a degree less than this one, which means this is 1x squared plus 0x minus 3. That's going to give me my other two zeros, and this time it is quad. So I can use my quad program to find the other zeros by going to quad program and putting in your A, B, and C. Well, A is 1. B is 0 and C is negative 3. Weird decimal, hit it enter again. There are the other zeros. Since that's 0, you don't even need it, right? Positive square root of 3 and negative square root of 3 are your other zeros besides the negative 2. All right, number 15. Gives me a function, f of x equals 11x to the 6th minus 4x to the 3rd plus 16x squared plus 10x plus 2. And this one wants to know what are all the possible rational zeros of this function. So this is where the possible rational zeros come from. Looking at the factors of the last term. So how do you multiply to get 2? This is good news because there's only one way to do that, 2 times 1. The denominators are all going to come from the leading terms coefficient. So 11's factors. Again, good news because there's only one way to multiply to get 11. Now, remember, these are going to be your numerators. You put the 2 over both of those, and you're using the positive and the negative of it. So positive and negative make 2 be your numerator. So 2 over 11, and positive and negative 2 over 1. It's just that 2 over 1 is just 2. So positive and negative 2 11ths, positive and negative 2. Then start all over and use the 1, this one, as your numerator. So you'll put it over 11 and 1. And again, it's the positive and the negative. So positive and negative 1 over 11, positive and negative 1 over 1, and 1 over 1 is just 1. All right, number 16. All right, the function is f of x equals 3x to the 3rd plus 5x squared plus 75x plus 125. And it wants me to find the rational zeros and any other zeros of this function. Okay, so I don't see factored form. So, and it's not quad, right? If it was quad, I'd just go straight to my quad program and find the zeros, but it's not quad, it's cubed. So I am going to try and factor this. There are 4 terms. So what does that tell you to do? Put them in groups. In my first group, it looks like I can pull out an x squared. So let's see what's left. If I took out an x squared from this first term, I'm left with 3x. If I took out the x squared from this term, I'm just left with the 5. This time I do see something in common. The greatest common factor of that second group is positive 25 goes into both of those. Let's see, that'll leave me with a 3x plus 5. Now remember, those are supposed to match. That's why they do. That is one of your factors. Your other factor is what you pulled out, x squared plus 25. Now, this means it's not all the way factored, right? But now it is quad. So I can find the other zeros from this one by putting it in quad. To find this one 0, since it's just an x, which is what I want it to be, I set it equal to 0 and solve it for x. So subtract 5s here. So 3x equals negative 5, divide by 3. So x equals negative 5/3. I'm going to put that one in quad since it's x squared. Now be careful. Remember where to find your a, b, and c. A is the number in front of x squared, so it'll be a 1. B is the number in front of your x. The x is the term that's missing, so that's why your b is 0. Your c is your constant, which is positive 25. So there's your a, b, and c. So 1, 0, 25. So there are the remaining zeros, 5i and negative 5i. So your rational 0 is this one, the one that's not an I or a square root. So it's going to be negative 5/3. The other zeros are 5i and negative 5i. Then it wants you to write out, once you get the zeros, it wants to say, okay, then what is the factorization? What are the factors that those zeros came from? Remember, we know how to go back and forth from zeros to factors. If this is a 0, what factor did it come from? It came from x minus 5i. Well, if this is a 0, it came from x plus 5i. Now this one, this is the other 0. I'm just going to track it back. What factor did it come from? That one right there came from 3x plus 5. So that's the factor that it came from. So there is the factorization of it. Okay, now it is 11:50. I'm going to keep going. Okay, let me pause this. Verse 17. All right, number 17 says find the domain of this function. F of x equals x to the third minus x squared plus x plus 3 over x squared plus 9x plus 18. Now, remember, when you are finding the domain of a rational function, you just want to find the zeros of the denominator. You don't even care about what's in the top. The zeros of the denominator and leave those out of your domain. So since my denominator is quad, I can find its zeros by using the quad function. A is 1, B is 9, C is 18. So if you put that in your quad function, you'll notice that the zeros of the denominator are -3 and -6. So that is what x cannot be. X cannot be -3 or -6. The other way it's going to ask you to enter it in after it asks you this way is interval notation. So in interval notation, I want to say all the numbers from -∞ to positive infinity, except for those two. Now, think about coming up the number line. If you start at negative infinity on the number line, there's 0, there's -6, there's -3, right? You have, this first parenthesis has to be what is farthest to the left on the number line, what number you're going to run into first. If not, your numbers are going to get out of order. So let's see, negative infinity to -6 in union with the numbers in between -6 and -3 are good, so that's how you would show that. And I want to also include the numbers above -3, which would be -3 to positive infinity. All right, number 18 is literally just like this, so I'm going to skip it. You'll just, again, put it in quad, get your zeros. In interval notation, the zeros were, it looks like -6 and 4. So just leave those out of the domain. So all the numbers except -6 and 4. Okay, going to number 19. This is talking about the asymptotes of a function, the vertical and horizontal. So let's recall how that works. The vertical asymptotes, remember those notes that I sent you for 8.5 that had all those different notes? I would have that handout handy during this part of the test, okay? The vertical asymptotes are going to be the zeros of the denominator that are not also zeros of your numerator. So if my function is r of x equals 9 over x squared minus 4, let's see, I can put that in quad to find the zeros of the denominator, or I can just factor that real fast because it's a difference of squares. It's not bad. X plus 2 and x minus 2. So the 0 coming from this factor would be -2. The 0 coming from that factor would be +2. So those are the zeros of the denominator. There's not any zeros in the numerator, so I don't even have to worry about that on this problem, right? If there's not an x up there, there's not any zeros. So your vertical asymptotes are x equals -2 and +2. What do vertical asymptotes look like? There are those dashed lines, and those will go vertically through +2 and -2. Okay? Then it's going to ask you a question about the oblique asymptote. We're not having any oblique asymptotes at all, so there is none. Now, the horizontal asymptote, now remember, that comes from that chart. Your horizontal asymptote comes when you are looking at the degree of the numerator compared to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, which is what's happening here, right? The numerator's degree is 0 because it doesn't even have an x. The degree of the bottom is 2. So the degree of the numerator is less than the degree of the denominator. That automatically means your horizontal asymptote is y equals 0. If the degree of the numerator is greater than the degree of the denominator, not in this case, but let's just say the degree of the numerator was higher than 2, that would mean there is no horizontal asymptote. If the degree of the numerator and the degree of the denominator are the same, they equal each other, that would mean your horizontal asymptote would be at y equals, then you would make a fraction of the leading coefficients. The top's leading coefficient over the bottoms. We're going to see one of those later to make that more clear. So Here's my vertical asymptotes. Here's my horizontal. Here's the problem with this question, because then we got to pick the graph. A and B both have those vertical and horizontal asymptotes, right? This one only has one vertical, and this one only has one vertical, so that's why it's not those. So I actually, even though it doesn't ask me in the problem, I'm going to have to find something else to distinguish what graph this is. If I'm not giving it in factored form, I'm not going to find X-intercepts, but if I'm giving it as the written out as the function, I'm just going to cover up the terms that have X's. I'm going to find what's called its Y-intercept, right? The Y-intercept happens or occurs wherever you plug in X's zeros. So if I put a 0 in place of that X, I'm going to be left with -9/4, which means this graph is going to cross the y-axis somewhere down in the negative. That's what distinguishes A from B. Look at A. Where is its y-intercept? I don't know exactly, but I know it's positive, right? It crosses it above. So that's why it's B. Number 20. Finding the vertical asymptotes of this function. So again, we're just finding vertical asymptotes this time, which means to find the zeros of the denominator that are not also zeros of the numerator. So let's see. First of all, I do notice that the numerator will have a 0. What is the number if you plugged it in and cubed it would give you 0? 0. So there is a 0 in the numerator. I just need to be conscious of that. I need to find the zeros of this denominator. It's not quad yet. It's cubic. But what do they all have? They all have an X. So I'm going to pull it out and put in parentheses what's left. They'll all just lose an X. So I have 4x squared minus X minus 5. So this is going to create a 0. My other two zeros are going to come from here, which now is quad, right? So now I can put in that to the quad. So let's see, A is going to be 4, B is -1, C is -5, hit enter. I'm going to have to enter it twice because it gave me a decimal. So 5/4 and -1 are the other zeros that came from the rest of that. So remember, vertical asymptotes are only zeros of the denominator that are not also zeros of the numerator. So since 0 is a 0 of the numerator, it cancels this one. So the only vertical asymptotes are at X equals 5/4 and -1. Number 21. This one's just a horizontal asymptote. All right, again, comparing, when you're doing horizontal asymptote, you're comparing the degrees. So the degree of the numerator, again, is less than the degree of the denominator. So if you look at your horizontal asymptote chart, that tells you the horizontal asymptote is automatically y equals 0 when the numerator is less than the denominator. All right, 22 asks us all the things. So let's write out our function. F of x equals equals x squared plus 2x minus 3 over x squared plus 5x plus 6. So it's going to ask me domain, x-intercept, y-intercept, vertical asymptote, horizontal asymptote. It's going to ask me everything. So the first thing I'm going to do, because a lot of that information comes from finding the zeros of the numerator and the denominator. So luckily for us, they're both quad. So I'm just going to find the zeros by punishing them in the quad formula. The top one's quad. A is 1, B is 2, C is -3. So its zeros are 1 and -3. There's the zeros of the numerator. I'm going to do the same thing on the denominator. Its A is 1, B is 5, and C is 6. So its zeros are -2 and -3. So this gives me something I need to pay attention to, right? They do have zeros that are the same, so that's going to mean something later. All right, the first thing it's going to ask me about this function is, what is its domain in interval notation? So remember, the domain, where do I go? The zeros of the denominator need to be omitted from the domain of the function. So let's see, x cannot be -2 or -3. It wants it in interval notation. So let's see. From -infinity, who am I going to run into first? I'm going to run into the -3 coming up from the bottom, right? I'm going to come into -3 first, so -infinity to -3 in union with in between those two numbers, so -3 to -2, and then the last part is -2 to infinity. So there's the domain. The next thing is going to be the x and y intercepts. Now, remember, when you're talking about intercepts, you're talking about physical points, right? It's the point where it crosses the x-axis and the y-axis. So remember, when you are a point, you are an ordered pair. So let's think about the x-intercepts ordered pair. If you, and again, this is in those 8.5 notes. X-intercepts come from zeros of the numerator that are not also zeros of the denominator. So that's why this -3 cancels. So the only x-intercept is at 1. When you're writing the ordered pair, the 1 goes in the x spot. The y is always 0 at your x-intercept. So there's the x-intercept. The y-intercept. So that's when we come to the original function and kind of imagine all the terms that have x's being gone, right? Because to find the x-intercept, that means I'm just going to replace all these, the y-intercept. I'm going to replace these x's with zeros, which is just going to knock them all out, which means what am I going to be left with? -3, 6, which reduces to -1/2. Remember, I'm talking about an ordered pair here. So the x at your y-intercept is 0. This number goes in your y spot. So just remember to type it in as an ordered pair. Then the last part is going to ask you about the vertical asymptote and the horizontal asymptote. The vertical asymptote comes from zeros of the denominator that are not also zeros of the numerator, which means -3 does not create a vertical asymptote, only -2 does. So x equals -2. And the horizontal asymptote. I'm looking at my degrees. This time, the degree of the top equals the degree of the bottom, which means your horizontal asymptote is going to come from this one's coefficient over this one's coefficient. So 1 over 1, or in other words, y equals 1. Then there's not an oblique asymptote. Now, picking out the graphs, I go here first, always. Your vertical asymptotes is only at -2. That's going to narrow it down. Yeah. A and C both have the vertical asymptote at -2. These, B and D, their vertical asymptotes are at +2. So that's why it's not B or D. So that vertical asymptote being at -2 narrowed it down. Then I go to my Y-intercept, not my Y-intercept, my horizontal asymptote, and it's supposed to be a +1. Well, A, you'll notice its horizontal asymptote is down below, so it's at -1. This one's horizontal asymptote is at +1. All right, so let's go to 24. This is the last section that we covered. It's going to be on this test talking about the inequalities being above or below 0. So let's see, this one is x minus 1, x plus 2 is less than 0. It wants to know where that is less than 0. Now remember, the two things that we were looking for were the x-intercepts of the graph, because the x-axis is what we're going to consider 0. Well, if I have factors, I can get pretty quickly to the x-intercepts, right? The x-intercepts just come from setting my factors equal to 0 and solving them for x. So here I would add the 1 to both sides. So x equals 1. Here I would subtract 2 from both sides. So x equals -2. So those are where it's going to cross the x-axis. At -2 and at +1. What kind of shape is this graph going to be? If I FOILed this, I'm going to get an x squared, right? What shape do x squared graphs make? U's. They make parabolas. So that's what that graph would look like. It's going to be a right side up parabola, since my x squared would be positive, passing through the x-axis at 1 and -2, and it wants to know, where is this below less than 0? Well, if this is 0, here's the interval that it's below the 0. So you're just going to write that in interval notation. The interval that it's below 0 starts at -2, and it's below 0 all until it gets to 1. So -2 to 1. Last one. All right, so that one I found the zeros or the x-intercepts by just setting the factors equal to 0 and solving them, since it was already factored for me. On 25, I've got x squared plus 9 is less than 4x. So first of all, I've got to set it equal to 0. So I'll subtract the 4x from both sides. So there's my less than 0. This minus 4x, I'm just going to put in between these two terms, right? Because it doesn't combine with any of them. And I want it to be in between them since it's the x. So x squared minus 4x plus 9. So this one's not in factored form. So to find its intercepts, or try to find its intercepts, I'm going to use my quad. So A would be 1, B would be -4, and C would be 9. What do you notice when you punch in and get your answer? What are the solutions or the zeros? 2 plus and minus I square root of 5. If these were x-intercepts, where in the world are you going to plot that? It's got an I in it. You can't put an I on the x-axis. You're not going to be able to plot that, which means, let's think about what that means about this parabola. So here's my 0. It doesn't cross the x-axis anywhere. Is this one right side up or upside down? It's right side up. A right side up parabola that doesn't have any x-intercepts is just going to be up there somewhere. That's the only way that's going to happen, right? If you're going to be a U shape, but you're not ever going to cross the x-axis, it's because your whole thing is above the x-axis. So what is this telling me? Where is it below? If this is 0, where is this ever going to be below 0? It's not. So that's why it's called the null set. You'll have that little symbol down there to push. Okay, so that is the review for test 3 that will be due on Sunday.